Hello, everyone. We are Team Legalese, and we want to improve legal question answering systems. Generally, when you think of lawyers, you think of people in a fancy suit in a fancy office with an almost empty file. But it ends up becoming this where people are drowning in the paperwork. So, the legal question answering system has three major challenges. Contracts are extremely long. The legal meaning of the words does not correspond to the natural language meaning, and the required context is generally spread out across the whole document. Our task description is such that we provide the model two things, the contract text and the question. And we aim to get a start index and end index highlighting the answer. Our data set is named Quad, and it has 510 SEC filings. Each of the contract can be extremely long, and it's the first expert annotated data set in this field. Moreover, we predict 44 unique question types. Once we did our analysis on the baseline models, we found three large sources of error. First was the legal language dependency. In this case, the question was, what is most favored nation clause? And the model overfit to the word favorable. The second source of error was the dependency on the question structure. The original question generally is long and it follows a fixed template. That is, highlight the something and then the field name and then the details of the field name. We experimented three things by changing the structure of the question. First was removing redundancy, that is remove highlight the yada 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 and just keep the field name and the contract and the details. The second was back translation, that is translating it into a different language and translating it back. And the third was cutting and mixing, that is keep the field name and jumble up the details of it to see on which portion of the question do we have a dependency on. And last source of error was the context size, where vanilla transformers have a limitation of 512 token size. So let's try to understand that a bit more. The attention computation is a big O of n square computation. Long former, by using sparsity and sliding windows, can compute the same thing in almost linear complexity. This allows us to increase the context size from 512 to 4096. The second innovation in our solution is the question augmentation. This normal data augmentation technique yielded really good results. And what we did was we just removed the redundant portions so that the model learns to focus on the important terms. We added these modifications as a part of the data set to increase our data set as well. The results were quite astonishing. A long former performed better than almost every other model in the same order of magnitude of results. And this we can see in AUPR and the precision at 70% recall. Only Roberta and DBERTA perform better. Moreover, we achieved the same thing that these people achieved in about 5% of the parameters. And that's the large takeaway. Note that Roberta was our baseline, and we almost reached its performance with about 5% of the parameters that was used in DBERTA. Lastly, we want to bring attention to auxiliary tasks because these are the scope of pre-training a legal language model. Clause type prediction and contract type prediction were tasks which we trained our models on and almost achieved a SOTA. The contract type prediction does not have previous literature, so we believe this is a good place where we can look into. The end goal of this pre-training would be just like language modeling looks into mass language modeling or next sentence prediction. We want to introduce these tasks to help the model understand legal language better. Thank you so much.